Hello everyone and welcome back. Today we'll be solving another interesting question called check sum tree. And here is the question. A sum tree is a binary tree where the value of a node is equal to the sum of the node present in the left subtree and the right subtree. You are given a binary tree and the task is to return true first in a case of the binary tree is a sum tree, else false in case of 0. Uh, okay, basically here you have to return true. In case of C, you have to return 1. In case false, you have to return 0. So, yeah, that's fine. Okay, so the question is pretty much straightforward, guys. All it is talking about is you have a binary tree. Let me just make this notes, okay? And you call this tree true when your current node is actually summation of your left tree and a right tree. So let's example, if I put here down 1 1 and 2 2, okay, I put 1 1, okay, you get 2 here, and then you get a 4 here. So let's assume that randomly, if I had this, what the tree is, this is should return back true. The reason for that is your current node is 4 and the left child is 2 and the right child is 2, which is actually equals to the current node. If you include the left plus right is actually equals to the current value, correct? Similarly, if you go down and check it out here also, here your left child is 1 and the right child is 1, and the which when you sum it up you're going to get 2, which is actually equal to the value. Similarly, that goes down to the fourth. So let's assume that what if your tree is something like this. If your tree is something like this, what if I had 2 here and then 2 plus 2, I'm just randomly adding 4 here. So in this case, it's not going to be true. The reason for that is because your 2 plus 2 is actually true, which is 2 here, but when you add 2 plus 4, you're not getting this. 2 plus 4 is actually equals to 6, guys, which is here 4. So it's actually going to be false. Okay. And I'll give you one more example. Instead of 4, what if I had, let's assume 9. Even in that case, it fails because 2 plus 2 is actually 4 and you were expecting a 4 but you get a 9 here. So even in that case, it falls, and here it's going to fail anyways because 9, this subtree is gone, so this entire subtree is gone. So at each and every node, you have to check that constraint. Okay, so let's take a look at the input. Here you have a big text tree, something like this. Here you have 666 and then 12, 12 and 48. So which is actually true because you have 6 and 6 which sum it up to 12, 6 and 6 which sum it up to 12, and 12 plus 12 you get 48, which is correct. So, pretty much straightforward, a typical tree. Very interesting question. I like it. I'm getting a lot of thought process, but I'm gonna give you guys an opportunity to think of on your own. Pause this video, go and try to solve it. Come up with some of the basic algorithm. Post that I will discuss how I'll be solving this question. Okay, yes. So the very first approach that is popping into my head is DFS, just do DFS. How about whatever the way I'm checking, like literally here, at every step, I'll just check if my current node is actually equals to sum of values of your left and right. So I am thinking of a recursive solution. And again, how do you find this left values? Again, that is going to be a summation of their left and their right. And at that step, I'll check it out. And if at any moment it is not equals to, then I'll just stop and return false. So it has to equal its current root and current value, and then it should also comes true for the rest of the root nodes and the rest of the nodes. So step number one is like a typical DFS search. Okay, so what I'm going to do is check. I'm going to do it recursively and get me a left sum and a right sum. Then once this is done, I'm going to check if my root equals to this left sum plus right sum, and I am going to call the same DFS check for the left node, and then DFS and it should be true. DFS check on the right node, guys. That's it. A typical recursive call. So let's head back. Again, most of the time I feel when we're talking about recursion and trees, it comes a bit tricky how the way you implement it. So They are important. They are algorithmic heavy, but at the same time, I feel these questions are also a bit implementation heavy. Okay. So having said that, we'll straight go into the implementation of it. Okay, guys, I'm done with my code. Let me quickly check if there are any syntactical mistakes. Okay, so a quick glance over the code. As I said, I'm going to use a DFS algorithm and I'm going to check. So first of all, I'm calculating my left sum and right sum. I'm using this helper method called sum, which is going to recursively crawl down from the current root node to the left side and the right side and give back the current sum. Okay, and then for the left subtree and the right subtree, I'm just checking if the current node value equals to left subtree's value plus the right subtree's value. If it is, that is true, and then I'm similarly checking for the left node and the right node. If at any moment in time this is not true, at any of this, you just return back true. So in this case, maybe this part of the tree is true, but this is false. So you crawl that back as false, 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 and eventually you'll get a false back, guys. That's all. Let's try submitting our code. Accepted. A summary to our question. A question is a typical tree-based question and very comparatively easy. You just need to check that if every node is actually a current node's value is actually sum of its left subtrees, left subnode plus the right subnode. And you need to check for each and every node in the rest of the tree. If it is true, then you have if the whole all the nodes of the trees, following the property, then you have to return true. If any of the node is not, you just have to return false. So we are using a DFS technique, checking the left subtree sum and the right subtree sum, and crawling through all the way from root to the all the leaves. Okay, yeah, so let me just explain the same question with the recursion stack for the example. Okay, so here is the code. Let me just rearrange it quickly. Yeah, that's all it is. Okay, so here is our recursion stack and how exactly this example is working. So as you can see here, I am writing this recursive function and eventually that is what is going to give you the final answer, whether it's true or false. Okay, so the checksum sum tree is the eventual thing. So as I explained earlier, I'm going to find out the left sum and the right sum, and then I'm going to just check if the current value is a current node is actually the summation of the left side and the right side, and I'm going to use this helper method called sum at every step to find out what is the sum, the entire left subtree and the right subtree, and how exactly this right subtree and left subtree works is. So let's start with this particular node. So this is where is your starting point. I'll insert 48. Okay. At this point, you come here, you find your ls. Okay. So I'll call this as 1 and 2. Okay. And while finding the ls, what you do is you call this helper method right here. And this node basically going to create. So this is the another stack for this sum, which is also again a recursion. So let me just call this as sum stack, and this is going to be checksum stack, checksum tree stack. Okay, CST is here. So once you have your sum, what I'm going to do is I'm going to check if my node is not equals to null. So it is not. So I'm going to insert 48. 40 is the first call which is being called. Okay, on top of that, then we return this node of left plus node value plus the node of the right. So what am I returning? I'm calling again two times. So first of all, left side, which is 12. I'm calling the 12. Okay, and then again the same story repeats. Again you come to the 12 and then again you go to the right of it, or sorry, left of it, which is 6. Okay, so right now you again call to the left side of it, which is null, so you return 0. So from this point you get a 0 back. Okay, and then again there's nothing here, so you get a 0 back. So once you come to the step 6, you will have 0 plus 6 plus 0. So that's what is going to return back to the entire tree, so to the 12 calls. So once this is done, you clear this out, and the value that you get from the ls is 6. Okay, so once you executed, like the 6 is popped out, you go and you call to the right side. So in the 12th call, you go and call the sum of right again. So you come here, you push 6 inside your stack, and then you can find out, go left, right, 0, 0 is the written, and you get 0 plus 6 plus 0 as the value. Okay, so here you get 6. So again, the 6 is going to get popped. So the value at 12, you returned both of this. This is 6 and this is 6. The value is 12. So that becomes total is going to be 6 plus 12 plus 6. Okay, so this value, that is what is going to return back. And then at 48, once you have the 6 plus 12 plus 6, okay, you are going to figure out what is the right side of it. So you get to try to figure out what is the right side of this. So again, you make a call, you go in and you make 12. Okay, you push 12 inside. Again, the 12 is going to push the remaining. I'm going to make a stack bit like this, 6. Okay, and again, you once you pop this out, you can push another 6. Let me take this row by row. So once you get here, again this will call the respective left side of the tree, which is 6, and then you return the 6 back because there's nothing. So you cut and you return 0 plus 6 plus 0, which is 6, as your left. Again you push 6 inside, again that get pops out. Okay, this will again return 0 plus 6 plus 0. Okay, and then at 12 you again return the entire thing, which is 6 plus 12 plus 6. So your left sum here initially is going to do this entire thing for the left subtree and going to return this as ls. Okay, ls, and this entire thing is going to be your rs for your 48 for the very first value. Okay, so again let me repeat myself. This entire thing is going to be ls and this entire thing is going to be rs for the root 48. So once this is done, here the 48 sum, your 1 is going to be this value here and this value here. You check. So your current node 48 equals to the r plus r, this thing, 6 plus 6, which is 12 plus 48. So that's what you're going to check, and then you continue the rest of the story. Again, you can call to the left side. So here at 40, since that is true, what you need to do is you go to the like 12, and you can check the similar thing. So here 12 gets pushed into the stack, and eventually you do the sum from 12 of left, and then the left, 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 and then eventually the right, 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 and then you get the sum, and you continue this as long as you have all the values true. So again, a 6 will be pushed here, and then this 6 gets popped, this will get popped. Similarly, this fashion you do. At every step, we go ahead and we try to find out recursively what is the left sum and the right sum, and then we put a checker on top of that. That's all, guys. Here's a recursion stack, and here's. Thank you so much.